This conference will now be recorded.
So no, cancel. So what you have to do, you just right click on the empty space, and yeah, select git bash here, not the GUI, git bash here option. Yeah, so now you are in the downloads directory. So now you can copy paste that ssh-i, it will work. Shift plus insert.
Command not found ಅಂತ ಇದೆ.
You have copied the this one something greater than sorry, what is this, backward slash e something.
ಇಲ್ಲ ಇದು ಎಕ್ಸಾಂಪಲ್ ಅಂತ ಅದೇ ಕಾಪಿ ಮಾಡ್ಕೊಂಡಿದ್ದು. ಸೊ ಕಮಾಂಡ್ ಕಾಪಿಡ್ ಅಂತ ಇದೆ.
That's what I am saying. You are not pasting it properly, or else right click paste. Yeah. Yeah.
ಓಕೆ.
Okay. So simply, if you run the command, it will not work. You have to go to that particular directory, or you have to give the full path of the directory. Only then the key will be accepted. Otherwise, it will not work. Okay.
ಓಕೆ ಗಾಟ್
Clear?
ಇಟ್. ಓಕೆ.
Okay. Anybody else having the doubt? Okay. So let us continue. So I'm sharing my screen. So yesterday we were discussing this concept of VPC peering. So I hope everyone have done this task, whatever I gave yesterday, right? That is VPC peering task. So this should be completed. And the same task you can do it for same account, same region, meaning both the VPC should be in the same region, and one VPC in one region, another VPC in another region of the same account. So you repeat this so that you get familiarized with the all the scenarios you can practice. Okay. So this I have given with the two different regions, and you can practice with different account also. Okay. Right. So this will be a real time task for you. Okay. So now going for forward. So this will be the story of every organization, and they will have multiple accounts. Okay, say they will some organization will have two accounts, some organization will have 4, 6, 8, 9, depending upon their use case. Okay, so some people production they will have separate account, UAT they will have different account. So production means it is a live where the real application will be hosted and the external end users will be using it, meaning it's a live one. Okay, so they will not tolerate any outages to the production. So that is why we have different other environments like test, UAT, pre-UAT, pre-production, okay, and dev environment. So in the dev environment, the lot of activities. Dev means development, UAT means user acceptance testing, right? Pre-UAT means pre-user acceptance testing. Test means test environment, so you can do whatever you want, so nothing is impacted. But you should always make sure that production environment in all organization you should be very very careful. And of course the for production environment you will not be granted an access at the early stages. So only they will give read only permissions and all those stuff which you are going to learn in the next module. Okay, and today we are going to complete with the VPC module, right? Now this looks good when we have only less number of VPCs. Okay, but what if there are 100 VPCs? So 100 VPC means, now as you can see here, if there are two VPCs you need one connections. If there are three VPCs, so 1, 2 and 3 connections. So A to B, B to C and C to A. So you require again for 3 VPCs 3 peering connections. So for that again you have to make a entry in the routing table. So this will be complex. For example, so there is a formula you can there is a formula where you can calculate the number of peering connections for the number of VPC. Suppose there are 10 VPC. So how many peering connections we can get? So the formula is n into n minus 1 divided by 2. So this is the formula. For example, if the where n is the number of VPCs. So if I have 10 VPCs, right? So if I have 10 VPCs, so 10 into 10 minus 1 divided by 2, that implies to, so 90, and 10 minus 1 is 9, and 9 into 10 is 90. 90 divided by 2, which is equal to 45 peering connection is required, which is very complex. Okay, so this kind of scenario like 100 VPCs, if there is 100 VPC, then 4000. So 100 minus 1 is 99, right? And yeah, 10 minus 1 is 90, and sorry, 100 minus 1 is 99, and 99 into
450, sir. 450.
450. So 450 peering connections will get. So it goes on and on. So that is why our routing table became complex, and it was very difficult to manage this kind of scenario. To answer to this problem, AWS introduced another service which is known as the transit gateway. Okay, so I was telling you, right? Not this one. This one. So transit gateway solves the problem of two things. One is you can have the transit gateway itself will creates its own routing table in the backend, so you don't need to scratch your head. Okay, so it is self-sustained and it will auto replicate the routes. You just need to add the connection. Okay, that is one point. And the another problem it solves is it will support transitive peering, meaning if you have the peering connection from A to B and there is a transit gateway, so you can have a centralized connection like this. So this is VPC peering. So before we have VPC peering, and this is the connection. So as you can see, A to B, B to E, E to C, C to D, there is all individual single connections. As you can see, destination B local, A peering connection. So these are all peering connection. But in order to solve this, so as you can see, I have given the formula also, right? So you can have a centralized VPC peering like this, right? Yeah, this is a transit gateway where all the VPCs are connected centrally like this as an attachments. Okay, or you can also consider this as an extension box where you can plug all your devices on a centrally one extension box, isn't it? Okay, but the only thing is this is not free like VPC peering. This is very expensive. So we are not going to do the hands-on for this, but I'm going to show you how we can create, because this service is very expensive, because in the back end they are going to dedicate one hardware appliances to our account. So that is the reason it is very expensive. But as a cloud and DevOps engineer, you should know, and not many organizations use this because of cost. Okay, so many people are happy with the VPC peering. Okay, like 1 to 2% or maximum 5 to 8% they will go with this kind of setup where they are ready to bear the cost. Okay, otherwise it is not required at all. Getting the point? So, and another advantage with the transitive pairing is you can create your on premises. So on premises means your apart from your application which are running in your office network, that also you can connect your transit gateway. Okay, so as you can see, with we have 3 VPCs and one on-premise network, and see the routing table. It's very simple, because transit gateway is so intelligent that in the backend it itself manages it. Okay, so here you have to take care of 3 things. One is the attachment. Okay, so first what you will do, you will create a transit gateway. Okay, it is similar to creating a IGW or a NAT gateway. Okay, so there is a separate section in the VPC. There you go and create the transit gateway. Once you create, it will take some time to be provisioning and become active. And to this you start attaching the VPCs or connecting the VPC. So that is called as the attachment. The connection from Amazon VPC and VPN to the transit gateway. And the route table used to route packets coming from an attachment, that is from an Amazon VPC and a VPN connection, that is called an association. So association means whatever the route tables are used to route the packets from, say, VPC A to VPC B, so that is called as the association. And propagation means whenever you are sending the data, say for example, now we are having 10 VPCs. Now all the VPCs are connected to the transit gateway T. So now if you want to send the data from A to, or for example VPC 1 to VPC 10, so the route table, and in that scenario the route table will get installed. Okay, so from A to 1 to 10 it has to go, then it will go via like this. I have given one example here. See, for example, if the, now this is X, Y, Z are called attachments. Why? Because VPC llama is connected to transit gateway via connection point X. That is called an attachment. Similarly, Y and Z. Okay. So this is called association. Association means llama will come from the connection Y, X, right? Not from Y, isn't it? So that is called as the association, meaning the route table which are used to route packets. So it can send the data via this connection only. So that is the route table. Okay. So this is the propagation. So propagation means the route table where the attachment routes are installed. See. So this is the attachment routes. So here it will get installed in the propagation section. And these are the actual route, because 10.1.0.0/16 via X. So it will come via X, and this will come via Y, and this will come via Z. Now see, there is one example I have given. See, 10.1.0.0, if the llama VPC wants to send the data to any Barry or the Pegasus, so it has to first send through the association X, and then that will be considered as a route, and then that is why it is listed in the propagations llama from X. Okay, and the route says the mentions the CADR. Okay, see here. Okay, yeah. So now this is one example. See here. So now packet source from llama and the destination is on premises. Now see how the packet will travel. So llama from X, llama from X, llama from Pegasus from Y, and on-prem from Q. Routes. So these are the routes. Okay. Now see here, in the next stage it has reached the transit gateway, and from the transit gateway it will reach us the on-premises through Q. So it will reach the transit gateway via X, this association, and the route is this one, 10.1.0.0/16 to this, and it will reach 172.16.0.0/16. Clear? So why people uses, because this is, as in the backend it is a physical device, dedicated physical device, so the connection speed will be very good. Okay, and you don't need to manage the routing table. You're getting the point. And you can have 10,000 routes per transit gateway, and you can connect 5,000 Amazon VPC attachments per transit gateway. So it is designed for this kind of workload. 5,000 VPC, it is totally very very big. Okay, for 5, 10 VPC and all, it is not required. Usually we will not find that many VPCs. Of course you will have minimum like 4, 5, something like that. Okay, yes. But if you are still interested, you can go through. If you are ready to bear the charges, I have given a step by step procedure in this document. You can configure. So this is also you have to do. So let me show you how you can configure the transit gateway. Then you will probably understand. So let me go to the VPC section, and as you can see, there is a separate under the VPN network. There is a transit gateway. Click here and you can create the transit gateway. Just give the name and leave everything as it is default and create the transit gateway. But I'm not going to create due to the cost restrictions. Okay, so once you create the transit gateway, it will say take some time, and it will generate a transit gateway ID. And then what we are going to do, we are going to attachments. Attachment means you will start connecting your VPCs or on-prem network to the transit gateway. Okay, and here after that you will get the route tables. So here automatically you don't need to create a routing table. Automatically it will get populated. Clear? So that is how the transit gateway works. So let me give you the official documentation. Transit gateway. Yeah, see here. So this is how it will work. Okay, you can connect any of the network. You can connect a VPN connection like this. Okay, this is a small diagram to demonstrate this. Okay, and if you click here, you will be redirected to this. Okay, 1 second. Yes, yeah. So this is the another architecture diagram. See, here there is a 3 VPCs and there is a centralized hub. Earlier there was one-to-one with VPC peering, like VPC B to VPC A, then VPC A to VPC C. It's not like that. With transitive peering, you can connect from A to B or A to C, whatever. So this is a centralized part. So that is the name they have given, transit gateway. Clear? See, the transit gateway automatically comes with the default route table. So you don't need to do that. It will automatically pick up. So this is the concept. Okay. Yes. So give me example. That's about the example. Okay, so now this brings to the end, and this one you can do on your own. So there is a, let me open and show it to you what and all you have to do. So there is a task here given. So wherein you have to create the VPC as per the, now this is how they will give in the real time. So they will list out the VPC in their Confluence page like this and with the respective CADR range, and you have to create. So they have given, now your ask is you have to create your 4 VPC with the following CIDR. Okay, then you have to create the respective subnets, and in the this availability zone US is 2A. So you have to find out, and then you have to name the VPC like this one, and they have to create the route table, meaning you have to create an internet gateway like this with the same naming convention. I told, right? Dev, QA, shared. Okay, CA means cross account dev. So these things you have to do it. Okay, and finally you have to create the routing table. So I will share this document with you. You have to finish this task. So at the end there is a Google spreadsheet you have to open and start working on it. So let me share it real quick. Uh, so you can start working on that. Okay, so now next part we are going to discuss on what are all the tasks they are going to give. Okay, so how to tell what is your day-to-day activity with respect to VPC. So that I am going to cover today now, and the interview questions. So I have divided the interview questions model wise. So you have to prepare, and also after the interview question discussion I'm also going to discuss what are the activities which you are doing in the your organization. Okay, so the first question is, it is basic on the CADR calculation. So they will give you any random number and they will give you, this is like irrelevant, you have to just focus on this thing. So they will ask you for 1000 IP addresses which CADR you will use. So you should be in a position to answer that. Okay, and the second question is, they are going to ask you private subnet versus public subnet. So private subnet means it will not have access to the internet gateway. It will follow the what private routing table, and whereas public will follow the public or route table or the main route table, which has a route to the internet gateway. Okay, so these are the difference you should give. Then how will you give secured network access to instances residing in private subnet, and why do we need NAT gateway? Or so they can rephrase the question like this. So okay, now you are telling private subnet does not have any internet connection, but they will require to download some packages. So how will you give access? Or what is NAT gateway? They may also ask you direct question. So you should say NAT gateway is abbreviation for network address translation, wherein it will be useful in providing the internet connection only for the outbound. You should be very clear. Outbound meaning means it is a one way. Nobody can connect from the outside to this private instance. Clear? So you should be in a position to say answer that. Next, what do you mean by routing tables or association? So routing table is like a map which the router looks into to propagate packets from source to destination, or it's like directions or a map, something like that, which refer to, or it is some sort of rules which the router refers to deliver the packets. Okay, now fifth question is like this question gets repeated in both the modules. One is in the VPC module and the other one is in the EC2 module, but both the ways it is the concept is same. Elastic IP is the permanent IP. Okay, for example, you might have noticed if you have already started practicing. Now what will happen if I now let me show you in a real way. I will show you, you will understand. So let me go to the EC2 section. Now I have an instance here, correct? So now this, okay, this does not have an IP. So let me terminate this and let me go back to Northern Virginia. Okay, so let me check in Mumbai. Okay, so yeah, so the typical behavior of any in AWS is this public IP will go off whenever you turn off the or stop the machine. You notice it. Okay, remember? So now whenever you, okay, let me turn on first. Now when I turn on, I will get back another one IP, new one, which is assigned to me by the AWS public IP pool. Okay, and I need to refresh it every time. And now I am getting this public IP, which is 184.72.84.155. Okay, but copy this and paste. Okay, now let me shut down. It's not required actually. So now I'm going to shut down. So this IP will be gone. Just a matter of a few seconds. This will go. Once it is stop, convert from stopping to stop, this IP will go. Yes. Now see. Now again, let me turn on. See, now again the IP is different, 54. Where is 54.90? Where is 184? So this is what I was trying to convey. So normally if you go with the normal public IP, it will keep on changing whenever you stop the instance and start back. So this behavior is common in AWS or in any other cloud provider. In order to solve this, there is a elastic IP, meaning there is a permanent IP which will be provided by AWS to your account. So only you can have per region 5 elastic IP, and you can see those in this section, network and security. Yeah, so this way I have allocated one IP for my Windows server. So that is 18.215.228.117. So no matter if I terminate, if I delete the server also, this IP will be there. So that is the meaning of elastic IP. So this elastic IP you have seen in the NAT gateway. While creating the NAT gateway, it was asking to attach the or allocate the elastic IP. Okay, getting the point? So this is the concept of elastic IP. Okay, please remember that the normal public IP will get, you know, I mean, we'll get back to the AWS IP pool, but whereas elastic IP, even if you terminate, it will not go back. So that is the concept. Okay, so the permanent public IP which we attach to the network interface card. Okay, security groups versus NSCL. Yesterday I have given in, in brackets. So you should tell only these 4 rules. That's it. Yesterday only I have explained, right? Then what is VPC peering? Explain the use case. Yesterday we did with the use case. When the use case is whenever you want to communicate across VPCs, then you will go with the VPC peering. Then why there is a need for transit gateway? If there are multiple like 1000 VPC, 2000 VPC, then we'll go with the transit gateway. Okay, and this is a common question. In some of them will ask what is VPC and what are its components. Like once you create VPC, what are the components? By default it's created, like you should start from a main routing table, then DHCP option set, DNS server, blah blah blah, all those things you should say. CIDR, ranges, IP address. Okay, then once you create subnets, in that there will be NACL, router, again routing tables, subnet associations. So all those things it is a, you should say. Then what is a bastion host? So bastion host is a, again I have given a classic explanation here, and I had given you the this one also, right? Where is that? Yeah, bastion host. So it is a way of connecting to the private instance via public instance. So the instance which is in the public subnet becomes the bastion host. Clear? I think I had put one link. Did somebody delete or something? There was a. This is VPC peering. Okay, let me give it again. I had given here yesterday. Okay, no issues. So I will give it here. Yeah, bastion host. So this is what. So Linux bastion. So if you click here, it will take you to the URL. So you can practice there. Okay. Yeah. Fine. So next question they are going to ask is, why don't we use default VPC? See, in every account you might have noticed that there is a default VPC like this. If you go to any region, say let me show you. Now I'm going to Tokyo. So AWS will create its own VPCs so that if there's someone who is not good at technically, he can make use of this VPC. See here, this is called default VPC. So default VPC will have its own say CIDR ranges, and it will have its own thing. So that is the reason we don't use the default VPC. Okay, so this should be the answer, and we can the customer requirement will be different. So that is the reason we don't use the default VPC. Next, again, what is meant by private IP, public IP, and elastic IP? Private IP is permanent, like EIP, but this is private and this is public. This IP you can use to connect within the VPC, whereas this IP and this IP you can use to connect from the outside, but the difference is this is temporary and this is permanent. So that's it. Okay. Next, what are the VPC limitations? So limitation means per region you can create only 5 VPCs, and per the VPC you can create 200 subnets. So 200 into 5, 1000 subnets you can create. Okay, next, what is the function of a VPC router? So router is the main thing or main operator inside the VPC which will control the flow of data or packets in and out of the VPC. So it is the main thing, and it will follow the routing table. So without routing table it will not do anything. Okay, clear? Now for AWS site-to-site VPN, and these are as I have already mentioned, these are optional, and this is advanced AWS topics. I'm going to give you links here. Okay, so site-to-site VPN. Site-to-site VPN. So site-to-site VPN is a mechanism where you connect two different cloud, or where you create like one cloud with the your office network. You're getting the point? Yeah, so this is the way. So this is your AWS network, and this is your on-premises network. Okay, and you create this as a one single private connection over the internet. Please remember this point, over the internet, and this is the very cheapest way to connect two of the client. You can not only on premises, you can create AWS with Azure also, but in our lab we don't have a Azure or on premises network. So that is the reason we are going to go with the only theory part. Okay, so this is again this will come under the advanced topics, so you need not worry. Okay, but as a knowledge you should know how it works, that's it. So usually the famous one is site to site VPN tunnel. Okay, so site to site VPN tunnel. So you just need to share the information with the on premises people. So there will be a network team here, and there will be a network team, that is you or your team. So you will create a virtual private gateway, and he will create a customer gateway, and each one will have their own public IP, and for that public IP you are going to share the some secret key. Then once those information is saved, then you can send the data from here to here without any hiccups. In the sense, as a private connection you will work. Okay, so I'm going to put the link here, you can. So how the AWS site is set to medium. Then next is, this is very rarely asked, so that is the reason. Then AWS VPC endpoints. So endpoints are basically to avoid some of the cost for the data transfer. Okay, see like this. So you will have a VPC, and you will have multiple services like S3 bucket, EC2. Okay, and if you have to send a huge amount of data from your VPC to S3 bucket, okay, you will learn all these things in the coming modules. But for now, you just understand that whenever you are sending the data from one service to the another service, it will go via public internet. So that will be costly. So to avoid that, you can create a VPC endpoint like this, where your data will be shared like this. If you are sending very less amount of data, that is okay, but if you are sending huge GBs of data, then you should go with the private connection, private links, or a VPC endpoints. Clear? Just a second. Okay, so you can go through this VPC endpoint. So once you create a VPC endpoint, so you can obviously send the data through that connection. Okay, so I'm going to use this, and I'm going to put it here. Sorry, here. Okay, so only these two are, you can say, advanced topics. Rest I have already covered, so you become perfect in these three other topics. Okay, now these are some of the question asked, interview questions. Okay, now coming to the activities, now they may ask you what you have done in the VPC with respect to VPC. You should say you have created the VPC as per the CIDR ranges provided by the client, and I have divided the VPC into subnets, private and public, as per the client needs. So client need means he will say he needs to place some 1,000 resources or 500 resources or 100 resources. Then you should place like that. Then you have created internet gateway and NAT gateway for the internet access on the public and private subnets. Then you will say IP filtering, meaning you have restricted access on the network level using the NACL, network access control list, based on the client IP addresses. Because what will happen now when you have dealing with the client, so only client wants to communicate, connect to this VPC. Nobody else wants to connect, because there will be some other hackers also, right? So for that reason, you are going to use the NACL here. Then you will say bastion host configuration for the secured access to the AWS private subnets. I will write here AWS private subnets or instances. You getting the point? Then you should say you have also configured routing tables and making the subnet private or public. So you should say that, and you should confidently say you have worked on peering connections between multiple VPCs like UAT and prod and dev and VPC. For example, our dev VPC might need access to UAT. So on that scenario, I have created a VPC peering connection. And I also know how to configure transit gateway if the number of VPCs are more. Example 100, 1000, 2000, like that. You have to tell me. But rarely transit gateway they will ask. Okay. So you should say all those things. Clear, guys? Any doubt so far? Okay. Yes, so I'm going to share this with you. Meanwhile, you can ask me any doubts if you have, please. And I have already shared you the task also. This one also I have shared. I can share you this book also if you want this book. You can share this if you want. Do you want this book? Okay, I will share you as well. So you can share, read it, and okay, this also I will share. You can go through. Okay, just check whether you're able to see it, or else it's okay. I have already shared the other ones. Yeah, that's it. Okay, no doubt, guys. Okay, and this one also, this is also another project. So you have to go through. So prepare well on the each module. So the more you practice, the more perfect you become, and quickly you will get the offer letter. So that is the mantra. That's it. Okay, so I have given all the links, so you can just follow and you can go ahead. Okay, come on. Any doubts? Okay, so if there are no doubts, I'm going to share one more document with you. So, which is not this, wait. So next we are going to start with the IAM. Okay, so please read some of the main, at least this page. Okay, before coming to the next class. Okay, tomorrow we are going to start with the new module, that is IAM, that is Identity and Access Management. Clear? So I'm going to share this with you. Okay then, so let me stop the recording if you guys have no doubt.